Hello students, this is Mrs. Wilborn again, and welcome to Lesson 4 in our Probability Unit. And this is the final lesson in this unit. And in this lesson we will cover information about two-way tables. This is a relatively short lesson, only a few slides to go through. Please have your guided notes ready so that you can copy down the information that you need. Okay, first off, this is about creating a two-way table, and in Lesson 3 we actually went ahead and defined what a two-way table was. And basically it is a way to display the outcomes of compound events. So things where you have two different things going on. So the question from the previous slide or the previous lesson about the outfits can be displayed in a two-way table. Notice that, let me get my pen going here. Notice that, sorry y'all. Okay, notice that across the top I have the different types of tops, a t-shirt, a button-down, or a sweater, and then along the side I have the pants, the jeans, the khakis, and the dress pants. So when I would make my table, I would want to put one event on the top and the other event on the side. That way I can then kind of like a coordinate plane put them into where they would meet would be the outcome of those two events combined. Alright, so let's go ahead and complete this table, and that way we can determine the probability, and then we'll be able to determine the probability that the outfit we will choose will have jeans with it. Alright, so let's look here. In the previous slide, or in the previous lesson, it talked about the different letters that we're going to use, so I'll go ahead and write those in there. So for a t-shirt, we'll put T, and for a button-down, we'll use BD. For a sweater, we'll use S. For jeans, J. For khakis, K. And for dress pants, we'll use the D. Alright, and so what we want to do is go ahead and just complete those things. So in this first box here, I would have the T and the J, meaning the t-shirt and the jeans. Notice that that's where they would intersect or where they would meet. Alright, in the second, I'm going to have the button-down and the jeans. And then finally, in the last row here, I would have the sweater and the jeans. All right, now I move on. Again, the t-shirt and the khakis, the button-down and the khakis, and finally the sweater and the khakis. All right, the t-shirt and the dress pants, oops, and the button-down and the dress pants, and then finally the sweater and the dress pants. So by completing the chart, now I can go through and answer the question. And the question is, determine the probability that the outfit you choose will have jeans in it. Alright, well we know that these three outfits here are going to be the ones that have jeans. So those are my favorable outcomes. Over my total outcomes, which I have three different outfits for each top, so that would be a total of 9 outcomes. Again, and I could just count the different matches, which would give me 1/3, which I believe matches what we said in Lesson 3 using the tree diagram. So this is just another way to represent your information or your outcomes, possible outcomes. So we have a 1/3% chance, or 1/3 chance of the outfit that we choose would have jeans in it. Alright, you can also use a two-way table to determine sample spaces from the possible outcomes. So what we need to do is determine what the sample space for this situation would look like. So let's go through and we'll again use our table and we'll fill in our letters. So we had TJ for t-shirt and jeans, BDJ for button-down and jeans, and SJ for sweater and jeans, TK t-shirt khakis, BDK button-down and khakis, and SK for sweater and khakis. T-shirt and dress pants, button-down and dress pants, and sweater and dress pants. And so what we want to look at is what is the probability of each of these things. So I'm going to run out of space at the bottom. Well, I'll just go down here. It's fine. So for genes, I have 1, 2, 3 possibilities that I would wear genes. So my representation of that would be 3 over 9, favorable outcomes over total outcomes, which again we're going to reduce to 1/3. All right, for khakis, I'm going to look again. I'll use a different symbol here. So I'm going to have 3 different scenarios to where I would have outfits that had khakis. So 3 over the total 9, the total doesn't change, and again I would reduce that to 1/3. And then finally the dress pants. Again, if I use a different symbol to represent these, so 3 outfits that would have dress pants over the total of 9 outfits, again, would give me 1/3. Alright, and so if I went through and I created my sample space, and to just check my work, again, jeans, I said there's a probability of 1/3, khakis 1/3, and dress pants 1/3. If I were to add these up, I would have 3 over 3, which is 1. And remember that the sample space will always add up to 1. The probabilities of each outcome when you're showing a sample space will always add up to 1. Okay, now it's your turn to try this. So here's your scenario. You roll a number cube or a dice and flip a coin. What is the probability that you get a 3 and a tails? Right, so think about that situation. Create a two-way table that would determine that situation, and then figure out what the probability is of getting a 3 and the tails. All right, this is one that you're going to work on your own, and then we'll go over the answer tomorrow. Good luck. This is the end of our probability lesson, and again, just come tomorrow with questions. All right.